Welcome to the CAEN spectroscopy video tutorials. In this video, we will learn to use the Input tab of the device settings window. First step, connect Hexagon to the detector and the Quantus software to the board as explained in the video tutorial Quantus Spectrum Acquisition. Second step, open the MCA Signal Inspector window as explained in the video tutorial MCA Signal Inspector. Third step, open the device settings window and click on the Input tab. The polarity section allows to set the polarity of the input signal coming from the detector. Once you have set the correct polarity, the MCA Signal Inspector will show you always a positive signal. If you see a negative signal, it means that your polarity settings is wrong. The Input Type section allows you to set the source of the input signal, a resistive feedback preamplifier, a transistor reset preamplifier, also known as TRP, and a PMT anode. The last two options allow to unlock the input coupling section and the protection setting section. These sections will be explained in the video tutorials TRP acquisition and PMT acquisition. The gain section allows to set the analog gain from 0.25 to 256 and the digital gain from 1 to 2.2. Set the gains according to the detector signal. The fast discriminator is a digital filter signal generating the trigger when an event occurs. In the MCA Signal Inspector, set fast discriminator on the analog probe 1 and threshold on probe 2. Then set trigger and armed on the digital probes. Stop the acquisition. The trigger logic is armed as soon as the fast discriminator signal overcome the threshold level. Then a trigger signal is generated as soon as a zero crossing occurs. The threshold can be set automatically or manually. It has to be set as low as possible to see low energy events, but high enough to not trigger only events due to the noise. You can also let the software decide the best threshold to apply. The software allows also to set fast discriminator shaping time. Since the fast discriminator is a digital filter, the shaping time acts on the bandwidth of the filter itself. As you can see, a long shaping time reduces the high frequency noise, allowing to reduce the threshold and to trigger low energy events. On the other hand, a fast shaping time allows to better distinguish two close events. The other two parameters of the auto set section are the DC offset and the trapezoid tail correction. The DC offset is an analog offset. It can be set automatically or manually as well. It allows to maximize the input dynamic range. It can be also set in the MCA Signal Inspector window. The last parameter is the trapezoid tail correction, which allows a correct evaluation of the incoming energy and of the trapezoid baseline. It is related to the decay time of the input exponential signal. It can be set automatically or manually as well. In the MCA Signal Inspector, set trapezoid as analog probe 1. The tail correction has to be set not too low because of the not correct flat top and the baseline overshoot after the trapezoid, but not too high because of the not correct flat top and the baseline undershoot after the trapezoid. By setting the correct value of the tail correction, you should see a real flat top as well as no tails at the end of the trapezoid. To have more information, check the application note Trapezoidal Filter, a Practical Approach. Tutorial completed. Check the CAEN website for other video tutorials. Thanks for watching.